Hello everyone, I am Someshra Janapati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. So as we are continuing with solving numericals and cantilever beam, here we have one numerical that we have one cantilever beam and two UDLs are here with 3-point loads at different stations. So our work is to find out shear force and bending moment at different points. So name it accordingly. So here we have A, B, C and D. As we already done before, we will calculate shear force and bending moment at these 4 points and then we'll draw shear force and bending moment diagram. So first thing we need to do is calculation of shear force. So as we know, when we calculate shear force, we will just do add the loads. So here at point, we will start from point B and here we will find out shear force at B. So you can see at B we have only point load, that is 2 kilonewton. So this will be 2 kilonewton. Okay. As we are calculating from right hand side. Okay. Always we need to remember, we need to fix one point and from that side we will calculate. So I have chosen here from right side. Next is your shear force at C. So shear force at C will be the 2 kilonewton, that is your point load, plus the UDL. UDL is applied here 2 kilonewton per meter and the distance is 3 meter. So here the UDL will be 2 into 3 and the point load, that is 3. So it will be 2 plus 6 plus 3. Here you will have 11 kilonewton of load. Then shear force at point D. So at point D you will have similar, like, okay, you can do this like we have up to point C 11 kilonewton, right? Now after point C we will add only this. So 11 kilonewton plus 5 kilonewton, that is your 16 kilonewton of load. Next is your shear force at A. Similarly, we have shear force up to this point, up to D point. So then 16 kilonewton will be add with the UDL of 1 kilonewton per meter, that is 2 meter. So 1 into 2. This will be 16 plus 2, that is 18 kilonewton of load. Okay. Here you have the shear forces at different points. So now let's calculate bending moment. Before going to calculate bending moment, let's have the shear force diagram first. So this will be your shear force diagram and this one for your bending moment diagram. Okay. So first thing, we have shear force at B, that is 2 kilonewton. So from this point we will have 2 kilonewton. Okay. Again 11 kilonewton load. Then we will have 16 and then we will have 18. So now our work is to join those lines. Okay. Let's do it roughly like, okay. So the diagram is going to be look like this. Always you can remember when we are drawing CO force diagram, in case of UDL or point load, so the diagram will be linear. Okay. Your diagram will be linear. It will be visible properly here, like this. So this part is your part of SFD. Here you have the SFD. You can write that is here you can have 18 kilonewton of load. This is your 16 kilonewton. This is your 11 kilonewton and here 2 kilonewton. What you got here? Okay. So you can check that is you have all positive shear forces. So here is your drawing is positive shear force diagram. Next work is to find out bending moment. So you can remember how to find out bending moment. So bending moment calculation is nothing but just multiply the load with the distance. Okay. So let's go for the calculation of bending moment. So first bending moment we will calculate at B. You can see bending moment at B. The distance will be 0. So we will multiply 2 into 0. That will be 0 kilonewton into meter. Next is bending moment at C. So what we will do? This 2 kilonewton point load will be multiplied with 3 and the sign will be negative. So 2 into 3, then minus of 2 into 3 into 3 by 2. Right? So it will be minus 6 minus 9. That will be minus of 15 kilonewton into meter. The first one is your 0 kilonewton into meter, and at point C we will have minus 15 kilonewton into meter. So third is our point D. So you can see here you have this load, this UDL and this point load. So let's start calculation. Bending moment at D, that will be minus of 2 into what? The distance will be this 3 plus 2. That is 5 and minus. So here you can see the UDL we have will be 2 into 3. Will be multiplied with what? This 3 by 2. Why 3 by 2? So just remember, here UDL is applying in these whole places. So we are taking 2 into 3 and up to from the midpoint. So we are multiplying 3 by 2. Okay. We are just converting this UDL to point load like 2 into 3 and when so this point load will be applied the mid distance. That's why we are multiplying 3 by 2 plus another distance that is 2 meter. Okay. Again, minus of 3 into 2. So we have minus 5 into 2, that is minus 10, minus 6 into 7 by 2, minus 6. So here we will have minus 10 minus 21 minus 6. So minus 21 minus 10 minus 31 minus 6, that is minus 37 kilonewton into meter. So this is your BMD, sorry, bending moment at point D. Next is your the last point and the support point. Bending moment at A, at support A. First, what? Minus of the last point load, that is 2. So here you need to multiply this point load, okay, this with the whole distance. So whole distance will be 3 meter plus 2 meter plus 2 meter. So minus 2 into 7, again minus the UDL one. So 2 into 3 will be multiplied with 3 by 2 plus the distance will be 2 plus 2, 4. Again minus of 3 into 4 minus of 5 into 2 again minus of 1 into 2 into 2 by 2. Okay. You can see the calculation here. So let's do our work, like minus 14 minus 6 into, this will be 11 by 2. Okay, minus 4 into 3, that is 12, minus 5 into 2, 10, and here minus 2. So it will be minus 14 minus 33, here minus 24, 12, 10 and 2, that is minus 24. So minus 24 minus 14, that is 71, minus 70 kilonewton into meter. Okay, the process is correct. For the correct answer, you need to calculate again and recheck it. But I know my answer is correct here. So we have the values of bending moment at A, B, C, D. And now our work is to draw the bending moment diagram. So one similar thing is here. You can see after this 0 kilonewton into meter, we have all the bending moment in negative sign. Okay, in negative sign. So let's draw the first at point B will be 0. Again, that is minus 15. Here you will have minus 15 kilonewton into meter. Again, bending moment at D, this is minus 37. Minus of 37 kilonewton into meter. Here minus of 71 kilonewton into meter. Okay. When we draw the bending moment diagram, we need to focus. Like in case of cantilever beam with UDL, we will have the diagram as parabolic. So this will be look like this. As here we have UDL. But here you can see there is no UDL, so we will draw the linear diagram. just a straight line. Okay. And again we have the UDL. So another parabolic here. You need to draw it properly, or you can do what? You can mention that here you have parabolic structure and here parabolic. But here you have the linear diagram. Okay. So that it will be clear easily. Here we have parabolic, we have parabolic and linear. And just mention these points with, so here negative bending moment diagram. So we have the shear force and bending moment diagram for A, B, C, D points and have clearly mentioned all the points. So you need to remember like where we draw the parabolic structure, where we draw the linear one. Okay. So now we have solved one numerical on this, and in our next classes we will solve more questions. So stay tuned. Thank you so much.